So the first one, I told you that the original is y equals f of x. The first one gives you these as transformations. It says y minus 4 equals f x minus 3. So the first thing I'm going to have to do is add the 4 over. Do I have any stretches? Do I have any reflections? The only thing I have is translations, right? I have a vertical translation. And these sentences have to be accurate. Vertical translation for units where? Up. And then a horizontal translation. Three units what? Always the opposite. Mapping and words are the same, right? So if I want to go 3 to the right, I'm going to go x plus 3. If I want to move 4 up, I'm going to go y plus 4. So that was number 1. Number 2. We have 3y plus 2 equals f of 2x. So we subtract our 2 first. Then what do we have to do? Most people forget to do the back number. Don't forget to divide both terms, right? Just so you know, I set you up as really ugly ones for a reason. So here we have a vertical stretch by a factor of 1/3 about the what axis? X, yeah. Did I give you any reflections? No, this was positive, this was positive. It is a horizontal stretch by a factor of what? Yeah, always flips. About the y-axis. And then a vertical translation 2/3 down. Mapping and words are the same. So my x, y. The only thing that affects my x is this 2. And I use a half in words, so I'm going to use a half in mapping. And then I do 1/3 y minus 2/3. The third one, I set you up for disaster. Because I set you up to do something that I haven't shown you that you have to do yet. So I'm expecting it to be wrong, because you've not learned it. Okay? So 3 has 5y equals f 2x plus 2. We've never had a horizontal stretch with a horizontal translation before. Now, when we were doing our horizontal translations in the past, I would give you like something like y equals f x minus 4. We agree? What's in front of my x? A 1. So in order to use horizontal or horizontal translations, we always have to have a 1 in front of our x. And currently I have a 2. So we're going to have to remember to GCF the 2 out. Or else our horizontal translations are going to be wrong every single time. Now, if there's a negative in front, same thing. If there's a negative or reflection, you have to take that out as well. Because we always have to have a 1 in front of our x in order to state our translations correctly. So I can divide the 5 over. I only have one term, so it's going to go in front. So I'm going to get y equals 1/5 f. And then I have to take the 2 out. 2x plus what? 1. So I always remember this. I will make sure and put like a 1 in front of there before I go to state anything. If I can't put a 1 in front of my x, I need to do something. It has to be a positive 1. So every single one of you is going to say 2 left, and it's 1 left, and I set you up because I didn't tell you you have to do that because that's in today's lesson. Yeah.
How do we do it if the coefficient of x can't be reduced to 1 by the...
Always can. So if you say it's like a half, you take a half out. When you divide by a half, it's like multiplying by a third. Or multiplying by 2. Multiplying by a third. So we go like, ooh, that's aggressively thick. This has nothing to do with this question. Don't look later and be like, how did you come up? So say I have f1/2 x plus 3. Let's say it's like that, right? So I take a half out, and I get a half out of a half is 1. And then 3 divided by a half is actually 3 times 2. So it actually becomes 6. Do you think they'll have the answer there to 3/2? Yeah, biggest oopsie. But remember, you can check these every single time. So whenever I GCF out, I will always, I just want to make sure I have enough brackets. Whenever I GCF out, I'll always distribute back to make sure I get the same thing back. If I don't, I oopsied on my GCF, right? So before I go to state any transformations, I'll always go, okay, take a half out, I get this, and I double check. A half times x is a half x. A half times 6 is 3, right? So you can double check. So whenever I GCF out, before I go to state anything, I double check by distributing it back in, see do I get back what I have. Then you'll catch yourself if you forget to divide by a half is multiplying by 2. Okay? Because if I did it as an oopsie and I said f1/2 x plus 3/2, let's say oopsie, I'll catch myself. This is 1/2 x, and then this is 3/4. Is that what it was? No, so that's why it doesn't work by just taking a half out of it, like that. Because whenever you're taking a GCF out, you're dividing. So that's what a GCF is, you're dividing it out. When you divide by a fraction, you actually multiply by its reciprocal. So if I have 3 divided by a half, that's actually 3 times 2/1, which is 6. That's what I'm getting for 6. Okay? Luckily here we didn't have that. But you also didn't know how to do it, so you would have missed it for sure, because I didn't show it to you, right? Expecting that. But I like doing it with a little shock and awe so that later on, when we go to do this, you'll remember it. Because what happens is, the common error is always the one where you forget to take that out. And then if they put a fraction, your second common error is when you divide by it, you don't actually flip it, right? Okay, so here we have a vertical stretch. By a factor of what? 1/5 or 5? 1/5. The vertical always stays. As long as you get into y equals. About the horizontal stretch by a factor of, always flips. About the and then we have a horizontal translation one unit. Where are we going? Because this is always the opposite, right? Or mapping in words or in a heart. So whatever numbers I use in mapping or in words, I'm going to use in mapping. We agree? So I have 1/5, I have a half, and I have 1 to the left, so that's like -1. That is what's going to come up in my mapping, right? Same numbers. Mapping in words, just say it in the heart. So we're going to have xy becomes, my x is going to be multiplied by a half, and then I'm moving 1 left, so -1, and my y is multiplied by 1/5. If you can get the mapping in words, do the same thing in a heart, and equation you have to flip for the x's, this unit's really easy. It's when people get them all like muddled, then it gets real ugly. Because all the common errors are if you muddle them. It's just sad, right? Okay, I'm going to get you guys to go to the board. We're going to practice some previous unit stuff. So we're combining all the transformations together today. We've combined them before anyways, and I kind of gave you a glimpse in the beginning stuff, a little reminder of what we did previous to the weekend. But we're doing the same things again. Here's a little rundown. Stretches, reflections, translations. This gets you a vertical stretch and the reflection in the x-axis, horizontal stretch, reflection in the y-axis, horizontal translation, vertical translation, right? So here it says A is a vertical stretch by a factor of A. If A is negative, then it is also a reflection in the x-axis, and x-intercepts are invariant. So if only A is done, then x-intercepts are invariant. If only B happens, then y-intercepts are invariant. And the reason why that is your mapping is xy becomes xay, correct? So if your A happens to be 0, it's going to stay 0, right? Same thing here, your y-intercepts. So if we have xy, it's going to be 1 over bxy. Well, if my point is 0y, it's going to stay 0y because no matter what I multiply by 0, it just stays the same, right? However, if I put a horizontal translation on there, it shifts it right off and it throws it right out. It's not invariant anymore. And then you have your horizontal and vertical translation. So this is just a little summary. So we're going to go down here. Describe how the graph of each of the following functions can be obtained from y equals f of x. So I want you to give me the transformations, and what else am I going to make you do? Mapping, because why not? That's what I say. You say why, I say why not. ABC, transformations and mapping. Try it out. Okay, so for the first one, we have a vertical stretch by a factor of 1/2 about the x-axis, and a vertical translation two units down. Nothing's happening to my x, so in my mapping, x, y, at the very least I know it's going to be x, comma, and then these are going to affect my y's. Because remember, unless it's in the brackets with the x, it affects the y's. So we have 1/2 and we have 2 down, so it's going to be 1/2 y minus 2, because mapping and words are the same thing. Then we look at b. Before I go to do anything, I say, okay, there's a 1 in front of my x, so I can carry on, correct? It's y equals and there's 1 in front of my x. Those are the key things I have to have in order to start talking. So I have a vertical stretch by a factor of 3 about the what? Which axis? X. Whenever it's with the y's, it affects the x-axis, right? Of the x-axis. It's a reflection in the x-axis because it's negative. Do you see how I didn't put a negative with this one? It can't be negative for a stretch, right? That's a reflection in the x-axis. And then a horizontal translation. Five units right. Now, it's the only thing that affects my x. So my x, y, I need to move 5 right. So I'm going to go x plus 5. And then any of the vertical or the reflections multiply, correct? The translations add, subtract. The reflections and the stretches multiply. So I have a vertical stretch by 3 and a reflection. So it's going to be negative 3 y. This one, before I go to state anything, I need to take the negative 2 out. So I'm going to get 4. It's in y equals, but there's no 1 in front of my x. So I take a negative 2 out, and I'm left with x. What's 10 divided by negative 2? Because when I GCF, I divide. Negative 5. Now this is all still with the x, because the big brackets are around the x's, right? Still affects my x's just like it normally does. Don't overthink it and be like, now it's not with the x, it is. But I have a 1 in front of my x, so my translation will be right. So I have a vertical stretch by a factor of 4 about the x-axis. I have a horizontal stretch by a factor of 1/2. Always flips about the y-axis. I have a negative in front, so it's a reflection in the y-axis. And then I have a horizontal translation. Five units, right. So this all affects my x. So my x is going to have a lot happening. So my xy is going to be negative a half x plus 5. Because if there's a reflection, it's negative. If it's half here, we write a half, right? And then my y is going to be 4y. Okay, example 2. The point m3n, so they give you a coordinate, just happens to not be like negative 6 and 5, it's m and 3n because they give variables, is on the curve of y equals f of x. Describe how the transformations affect the ordered pair, and then actually give me the new ordered pair. Okay, so I want you to describe the transformations and then give me the new ordered pair. So try example 2. What's the first thing I have to do?
Take like the negative.
You have to take out the negative 1. If it's a number in front, I know there's a better chance of people remembering it than if there's just a negative. Because a negative doesn't scream, take me out there. But a number does. So I know that if there's a number, more people will remember. If it's a negative, some people will remember. And then there's going to be people who are never going to remember to take out the GCF. It just doesn't happen until like 4th unit. So I hope you're not those people. So we have a negative 1 sitting in front and we need a positive 1. So we're going to get y equals 2 f negative 1 x minus 3. And if you forget to take the negative 1 out, your horizontal translation will be the wrong direction every single time. Right? Because it flips that sign. So our transformations are vertical stretch by a factor of 2 about the x-axis. There's no horizontal stretch, but there is a reflection in the y-axis. And then a horizontal translation. Three units, right? And a vertical translation. One unit down. Then we need to use our mapping. So xy becomes negative x, and then plus 3, 2y minus 1. The y should be easy because the y never changes in words, in mapping, in anything. The y's just stay the same as long as you get it in y equals. So we plug in our coordinate. We get mn. I hope you're doing it like this. You have to show it with the brackets and the arrow in between because that is mapping. And then we go mn becomes negative m plus 3, comma 2n minus 1. That's as good as it gets. That's the new point. Yeah.
It's 3n in the original.
It's true that, sister. I have to erase. Just omitted that 3. That is right there is where you lose marks. Not paying close enough attention. Or rushing. All right. I'll flip to the next one. Okay, you're doing example 3. Write an equation. It should be quick. So this one is the parent function is just the basic x cubed graph, right? It's not like it's a moved one and then we have to move it some more. That's when it gets more complicated. So when it's just a parent function, you can actually put everything in right on the right-hand side. So stretch vertically by a factor of 3. We're going to get a 3. reflected in the y-axis means my x is negative. And then translated to left, you have to watch yourself because it needs to have a 1 in front of it, correct? So translated to left, I'm going to put a bracket, plus 2, close it, and I have to have a what on here? The cubed. And then 4 up. And this should be g of x. It says transform to g of x. I don't know why. So make sure when you're putting in your equation that you have a 1 in front of your x. Yeah.
Why do we put the index on the outside of the x's?
Why do we do that?
Yeah, the 3.
This 3? Because it's vertically stretched by a factor of 3.
Or no, the one, like the negative x plus 2 raised to the 3.
This?
Yeah.
Because this is my x. And previously my x was cubed.
Okay.
Like if you look here, this is an x cubed, right? Had I given you, let's say I gave you y equals the square root of x, then the square root's like the brackets. So I would go g of x equals 3 square root negative x plus 2 plus 4. So it has to go in the x spot. That one just happened to be, this is like this, just they don't write the bracket because they don't have to because there's nothing with it. So if it was an x squared, it would go with the x. Square root goes with the x. 1 over x plus 3, it would have to go with that x. Like it just depends on where the x is. Does that make more sense?
Yeah, curious.
Just put brackets.
The original.
Yeah. And the other ones we've only done so far are ones with f, right? But they can give you a function that's a cubic or a radical or rational.
Okay. And
Okay.
so in this case, do you need to put the f, or is that sufficient?
You can't put the f because they want a new function g. So if the original isn't just an f of x function and it's an actual function, like this is a cubic, we have to have a cubic. Yeah, good.
So you carry the old function into the new function, which up to this point is just the f of x.
Right.
Okay.
The very first day, we did ones where it was like root x, 1 over root x, some of those. But yeah. All right. So your homework for this is page 39. Number 5b, 6cd, 7de, nope, 7df, 8b, 9ef. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Tomorrow we're going to do 10 together and start practicing the diploma style, which are always different, right? You have to spot whether the original function is a function or if it's an f of x function or if it's a parent function, if it's been transformed to transformed, basic to transformed.